All right, so welcome to my series on managerial economics. And in this section, I'll be teaching on the Cournot model, which is a follow-up from the models of oligopoly. So if you have not watched the first video, please kindly watch it, as it will give you more insight on this on this one and that I'm about to do. All right, so as part of the models of oligopoly, we've already studied on the Sweezy model. All right, and this one is the Cournot model. So I'll urge all of you who are watching and who are learning that kindly subscribe, share, comment, and let us have your feedback so that we can bring more of this content to you. All right, so we would talk about the Cournot model as a model of oligopoly. Now, here, in the Cournot model, these are the characteristics that we need to pay attention to. Now, in the Cournot model also, there are a few firms that are either perfect substitute or imperfect substitute. So in a Cournot model, the firms there, they sell differentiated products or they sell similar products. Now, because of this, their main control variable is not the price, but their main control variable is the output. Now, this is the key feature of a Cournot model. In a Cournot model, each firm believes their rivals will hold their output constant if it changes its own output. Okay, so in essence, the output of rivals is always viewed as given or is always viewed as fixed. All right, so in simple terms to understand, what we are saying here is that in a Cournot model, if I am firm A, I'll make my output decision based on the fact that firm B, who is my rival, will maintain his. All right, based on the fact that firm B, who is my rival, will maintain his. On the other side, too, firm B will also make his output decision based on the fact that mine is also fixed, or mine is also maintained. All right, so that is the idea behind Cournot model. Cournot model, the control variable is the quantity or the output, and each firm makes its own output decision, thinking that the other firm will not change his. All right, and then the other firm to make his output decision based on the fact that the first firm will also not change its output. All right, so each firm takes the other firm's output as given or fixed. And also another key feature of the Cournot model is that there is barriers to entry. Now, here, what this will mean is that if each firm makes if each firm takes its output decision based on the fact that the other one will not change his output decision, that means that each firm will also determine its profit maximizing output on the assumption that the other firm will not change its output. All right. So of course, I will make my output decisions based on the fact that the other firm will not change his output. That means that, of course, if I'm making my output decision, I'll not just make any output decision. I'll make a profit maximizing output decision. All right. Okay. All right. So that is that. On the other hand, the other firm too will also make his profit maximizing output decision based on the fact that I will not change mine. All right. So here, the simultaneous decision that I will make decision based on the fact that the other will not change it, and the other two will make decision based on the fact that I will not change my output, will lead us to the equilibrium situation. All right. That will lead us to the equilibrium position or the equilibrium situation. Okay. Now, what we need to know is a concept called reaction function. Reaction function. What we need to know is a concept called reaction function. All right. So if I make my output decisions, in fact, my profit maximizing output decisions based on the fact that the other will not change his, it means that I will react to the other's output, right? I will react, or my output is based on the other's output, right? So that is the meaning of reaction function. Okay, so it's like a simple dependent and independent variable. If my output decision depends on your output decision, it means that my output decision will react to your output decision. All right. So as an equation that summarizes how my output decision is based on the output decision of my rival, or how my output decision reacts to the output decision of my rival, is called the reaction function. Okay, that means that in a typical oligopoly where there are two firms, we call it duopoly. When there are three firms, we call it tripoly. Four firms, we can have quadrupoly and all that. But here we are restricting ourselves to only two firms, a duopoly situation. All right. So in a duopoly situation, firm A will have a reaction function, or firm A output decision will be based on firm 2's output decision, and firm 2's output decision will be based on firm 1's output decision. All right. So in other words, firm A's output decision can be based on firm B's output decision, and firm B's output decision can be based on firm A's output decision. And this is just rational because you can only select your output based on the output of another person if the other person will not change it. Once the other person will change his output, you cannot conveniently select yours based on his, because by the time you select yours based on his, he would have changed it, right? So here, the managers assume that they are choosing their quantity based on the fact that the other person will not change his. Now, we can draw a graph of a reaction function. Okay, we can draw a graph of a reaction function to determine the equilibrium output. And we will do that when we are solving a question. Okay. So this is how, or these are the steps that will be used to draw the reaction functions on a graph. And as I said, we will look at that in detail when we pick a question, right? We will look at that when we pick a question. Okay, now, when do we achieve an equilibrium in a Cournot situation? When do we achieve an equilibrium in a Cournot situation? Now, because the two firms are making simultaneous decisions, in other words, because firm A makes a decision of its output based on the fact that firm B will not change his, and firm B also make output decisions based on the fact that firm A will not change his, what it means is that the two firms are making simultaneous decisions. And then to achieve the Cournot equilibrium, it means that we have to solve the two reaction functions simultaneously to come out with the answer. Now, here in solving the reaction functions simultaneously, what I want us to know is that we have to use the substitution method. You can use elimination method, you are not wrong, but the substitution method makes better Cournot sense than using the elimination method. Because the substitution method, you put one firm's output in another firm's reaction function, and that will make better Cournot analysis or better Cournot sense than doing the elimination method. Okay, so this is the equilibrium point. The equilibrium point is when we solve the two reaction functions simultaneously. On the graph, the equilibrium point is the intersection of the two reaction functions. Okay, all right. So this is the summary before we enter into the quantitative analysis. So the summary of Cournot is that the output K1, or the output of firm 1, maximizes firm 1's profit, given that firm 2 produces quantity 2, which is fixed. On the other hand, the output of firm 2 maximizes firm 2's profit, given that firm 1 produces a fixed quantity. So at this point in time, no firm has an incentive to change its output because he knows that he's choosing output based on the other person. The other person also knows that he's choosing output based on the first person. All right. So one of the things you must also know is that the beliefs are consistent. Each firm thinks the rival will stick to their current output, and they all do at the end of the day. Okay, so let's enter into the quantitative Cournot analysis. Now, in finding the equilibrium point in a Cournot analysis, the first point is to find the reaction function of each firm. This is because each firm makes decision taking the other's output as given, all right? So, for instance, if you are given an inverse demand function like P is equal to A minus B into bracket Q1 plus Q2, where Q1 is the output of firm 1, Q2 is the output of firm 2. And then the total cost is the fixed cost. So the total cost of firm 1 is the fixed cost of firm 1 plus the variable cost of firm 1. So if you look at this function here, it means that the FC represents the fixed cost, and then the C1 here alone represents the average variable cost. Okay, the C1 here represents the average variable cost because the total variable cost is C1 over Q1. So if you want to look at average variable cost, it will be total variable cost divided by the quantity, which will give us C1 Q1 over Q1. So when K1 and Q1 cancels, the average variable cost is the C1. So note that the C1 in the formula represents the average variable cost. Now, another thing I would want us to know in the formula again is that whenever we are given a linear total cost function, a linear total cost function means that the function does not have quadratics, like this one. This function here does not have quadratics, okay? So once we find the marginal cost 1, it will be change in total cost 1 over change in quantity 1. And if you do it, the fixed cost will tend to 0 because fixed cost does, when we differentiate a fixed cost, it will tend to 0. Then for the marginal cost, 1 will multiply the C1, then we subtract 1 from the power. So it means that the Q1 will also get missing. So the marginal cost is equal to what? C1. So another lesson I would want us to learn is that if we are given a linear cost function and the cost function is not quadratic, okay, the C1 in the formula here is also marginal cost. So given a linear cost function, the C1 in the formula is marginal cost and it's also the same as the average variable cost, okay? So when you are given a marginal cost in the question, don't say we were not given average variable cost. I've told you that given a linear cost function, the marginal cost is the same as the average variable cost, okay? And the same thing applies to firm 2. Firm 2, this is total cost 2, this is fixed cost 2. The C2 here is the marginal cost of firm 2 as well as the average variable cost of firm 2, all right? And then this is supposed to be 2. And then scale 2 is the quantity 2 or the quantity of firm 2. Now, given all this, what is the formula for the reaction function? So the formula for reaction function 1 is A minus C1. A represents the constant in the inverse demand function. A represents the constant in the inverse demand function. So A minus C1. C1 is the average variable cost of firm 1 or the marginal cost of firm 1 if the cost function is not quadratic, if it is linear, all right? And then the B here represents the coefficient of the quantities in the inverse demand function, okay? And the same thing applies to, so everything here will be given in the question minus 0.5 Q2. The 0.5 is fixed no matter what, right? So minus 0.5 Q2. And then Q2 is also equal to A minus the marginal cost of firm 2 over 2 times the coefficient of the quantities in the inverse demand function, that is B, minus 0.5 Q1. Okay. Now, having gotten the reaction functions, I've told you that the next step is to solve the reaction functions simultaneously using the substitution method. So this will help us get the equilibrium quantities of firm 1 and firm 2 in the Cournot situation. Now, managers are not only interested in the equilibrium or the profit maximizing quantities, the managers would also need to know the profit itself. So if you want to look at profit for firm 1, okay, profit for firm 1 is Q1 into bracket the industry price minus the average variable cost of firm 1, or the marginal cost of firm 1 if the cost function is linear. Okay, bracket close, minus fixed cost 1, right? Then the profit for firm 2 is Q2 into bracket the industry price minus the average variable cost of firm 2, or the marginal cost of firm 2 if the cost function is linear, bracket close, minus fixed cost 2. So this is how we get their profit. Mind you, the industry price itself is gotten by substituting the Q1 plus Q2 into the inverse demand function. Of course, the industry profit is gotten by adding profit of firm 1 and firm 2. Okay, of firm 1 and 2. Okay, so now let's take an example here. This example says that suppose the inverse demand curve for 2 Cournot duopolies is given by P is equal to 10 minus Q1 plus Q2. The function is given as P is equal to 10 minus Q1 plus Q2, right? 10 minus Q1 plus Q2. Then the question says that the costs are 0. The costs, that means that the total cost is 0, the fixed cost is 0, the marginal cost is 0, the average variable cost is 0. All forms of cost are 0, right? What are the reaction function of the two firms? What are the Cournot equilibrium outputs? What is the equilibrium price? And what is the profit for each firm? And then the total industry profit. Okay. Now, the inverse demand function is given as P is equal to A minus B Q1 plus Q2. Okay. So in the question that we are solving, the inverse demand function was given as P is equal to 10 minus Q1 plus Q2. So that means that the coefficient in front of this bracket is technically 1 because it was silent, so it is 1. Okay, so mimicking this, we can clearly see that A is equal to 10, B is equal to 1. Okay, A is equal to 10, B is equal to 1. All right. Then the question says that all the costs are 0. So it means that the total cost itself is 0. Okay, the total cost itself is 0. That's total cost for firm 1 is 0. Total cost for firm 2 is also 0. Now, using our formulas to get the reaction function, the reaction function of firm 1 is Q1 is equal to A minus C1 over 2B minus 0.5 Q2. So here you have Q1 is equal to our A is 10. The C1, which represents the average variable cost, is 0 because if total cost is 0, fixed cost will be 0, average variable cost will be 0, marginal cost will be 0. So it means that the C1 here is 0 over 2B. The B is 1, as I've shown you from here. So B is 1 over 2 into bracket 1 minus 0.5 Q2. All right. So we have Q1 is equal to 5 minus 0.5 Q2. Let's also, so there's a reaction function for firm 1. Let's also find the reaction function for firm 2. So Q2 is equal to A minus C2 over 2B minus 0.5 Q1. Okay. Also, the A is 10. Because all the costs are 0, the average variable cost C2 itself is also 0, all over 2 into brackets 1 minus 0.5 Q1. So if you solve everything, you get Q2 is equal to 5 minus 0.5 Q1. And this is also the reaction function of firm 2. All right. Now remember, the next step is to solve these two reaction functions simultaneously. The next step is to solve these two reaction functions simultaneously. All right. So we have Q1 is equal to 5 minus 0.5 Q2. And Q2 is also equal to 5 minus 0.5 Q1. Okay. So we have equation 1 and we have equation 2. So solving them simultaneously, we say put equation 2 in 1. Put equation 2 in equation 1. So we will have Q1 is equal to 5 minus 0.5. Whenever we see Q2, we can put the Q2 function there into bracket 5 minus 0.5 Q1. So we have Q1 is equal to 5 minus 0.5 times 5. We will get negative 2.5. The negative 0.5. So first of all, negative 0.5 times 5, you get negative 2.5. Then negative 0.5 times negative 0.5, we have plus 0.25 Q1. All right. So let's summarize. 5 minus 0.5 minus 2.5 is 2.5. And then this 2.5 Q1 would, 5 minus 2.5, we will get 2.5 plus 0.25 Q1. So we have this. So when the 0.25 crosses to the other side, we are grouping like them. We will have Q1 minus 0.25 Q1 is equal to 2.5. So we have 0.75 Q1 is equal to 2.5. We have Q1 is equal to 2.5 divided by, we have 2.5 divided by 0.75. So the final answer, you get 10 over 3 in fraction, or you get 3.333 reoccurring. Now remember that Q2 is also equal to 5 minus 0.5 Q1. So we can now substitute Q1 in this. So we will have 5 minus 0.5 into bracket 10 over 3. So Q2, if you solve it well, the answer will also be equal to 10 over 3, or 3.333 reoccurring. Okay, 3.333 reoccurring. Okay. So we've gotten the quantities that will maximize profit. We've gotten the quantities that will maximize profit. Now let's go and check the maximum profit for the two firms. Remember that I told you that once we have a linear demand function, their profit can be gotten using a certain formula, right? Their profit can be gotten using a certain formula. But before that, we need to find the industry price. So the price is equal to 10 minus Q1 plus Q2. Okay, so we will have 10 minus 10 over 3 plus 10 over 3. If you solve it well, you should have the final answer to be 10 over 3 or 3.333. All right. Now let's go and find the industry profit. Profit for firm 1 is equal to quantity 1 into bracket price minus the average variable cost 1, bracket close, minus the fixed cost 1. Okay. So here, the profit for firm 1 will be equal to Q1 was 10 over 3 The price was 10/3. Now, there is no average variable cost or there is no marginal cost. There's no C1 because the question says that all the costs of the firm are 0. So it means that this thing is 0, then the fixed cost itself is also 0. So when you solve it, our final answer will be 100/6. Okay, it will be 100/6, or when you divide it by 2, you get 50/3. That will be the final profit answer for firm 1. For firm 2 as well, we will have K02 into bracket price minus average variable cost 1 minus, average variable cost 2 minus fixed cost 2. So here we will have 10/3 into bracket 10/3 minus 0 minus 0, because there is no average variable cost 2, there is no fixed cost 2. So when you solve it, you also get 100/6, which is also the same as 50/3. And if you want to find the industry profit, it will be profit for firm 1 plus profit for firm 2. This will give us 50/3 plus 50/3, and this will give us 100/3. And that is the industry profit. That is the industry profit. Okay, that is the industry profit. All right. So this will be our first example on Cournot. All right. I will entreat us that let's watch the video on further examples on Cournot. But in this, to explain the concept, I would end here with this first example. So make sure you find the next video on further examples on Cournot, or further examples on quantitative Cournot analysis. All right. So we'll end here, and then we'll meet in the next video to solve further examples or further quantitative analysis of Cournot. Do well to subscribe, share, comment, and then like. All right. So we'll meet in the next video on quantitative analysis of Cournot, and then we'll be solving more examples there. Okay. All right.